Hello everyone, I'm Christina and welcome to video 13 of our A-Level Mathematics Calculus series. In this video, we're looking at second order derivatives. So our objectives for this video are to give the definition of a second order derivative and to calculate second order derivatives. So let's start with the definition. So for a function f of x, differentiating twice gives you the second order derivative of a function. So that's f double dash of x or d squared y over dx squared. So the second order derivative gives the rate of change of the gradient function. And we will explore this further when we look at turning points. Now, the definition we've given here is to differentiate twice to get the second order derivative. We can also break that down a bit further because let's say for f of x, the first derivative is f dash of x. If we wanted to get the second derivative, then we could just differentiate the first derivative once more. Okay, so then what that means is we can either differentiate f of x twice, or we can differentiate f dash of x once to get the second derivative. So now let's try calculating the second derivative. So in this example, we first want to calculate dy over dx, so that's the first derivative, also f dash of x. But we also want to calculate the second derivative, or f double dash of x. So we have y equals x squared plus 3x plus 2 over x. So let's just rewrite this to make it slightly easier to work with. So let's divide each term by x. So the first term, x squared divided by x, that's going to give us x. And then the second term, plus 3x over x, that's just plus 3. And then the third term, 2 over x, well, that's just 2 over x, but we can also write that as plus 2x to the minus 1. So first we want to calculate dy over dx. So we apply our rules for differentiating powers of x. If we differentiate x, we just get 1. If we differentiate 3, that's just a constant, so we get nothing. And then if we want to differentiate 2x to the minus 1, remember we bring down the power and multiply it by the coefficient, and then we take away 1 from the index. So we get minus 1 times 2 times x to the power of minus 2. So let me write it like that. So that's minus 1 times 2 times x to the minus 2. That's equal to 1 minus 2x to the minus 2. Or 1 minus 2 over x squared. So that's our dy over dx. And now we want d squared y over dx squared. So we want the second derivative. So the easiest way to do that is to differentiate the first derivative. So if we're doing d squared y over dx squared, that's the same as doing d over dx of dy over dx. Okay, and we write it like that. So when we differentiate the when we differentiate the first derivative here. So then that's equal to d over dx of 1 minus 2 over x squared, as that is our dy over dx. And so we go through the same process again of differentiating each term. If we differentiate a constant, we always get 0, so that's nothing. And then all that's left for us to do is to differentiate this term here. So again, we can write that as d over dx. In fact, I'll just write 0 first, as we get 0 from differentiating a constant. And then what we have here is plus d over dx of minus 2 over x squared. That's equal to 0 plus d over dx of minus 2 times x to the minus 2. And so again, let's just bring down the minus 2, multiply it by our coefficient here, and then take away 1 from the index there. And so what we're left with is minus 2 times minus 2 times x to the minus 3. And that's 4x to the minus 3, or 4 over x cubed. And there we found the second derivative of our original function here.